me. All right, it's a little rough. Okay, so the kids are really excited. We are having technical difficulties once again. It's not working. All right, I can do this. Cool. All right, guys, the do now. Today's notes, day 85. You do need a calculator for this. Anyone need to borrow a calculator? Oh, pass this one back. Get another one to pass back. You pass that back too. Thanks. Sorry. I'm sorry. Okay. All right, guys, what mode do you have to be in this class? Oh, that was good. All right, we're back on track now. All right, so you're given f of 1, you're given the derivative of f, and you got to find f of negative 1. You already got it? I can't come near. Look at. Oh, you got it already. Angela, go around and check people's papers. Oh, welcome to my world, Angela. Okay, they're waiting for you to just do it for them. This isn't a race. Yes, you definitely won. Angela won. No, I don't know how to do that. So all right. This, this is crazy. I don't know why this is like this. So you don't really hear it as too much. You're not really going to. It's very low. But you know what? I don't. All right, guys. Actually, before we go to the answer, I don't think I'm going to record this. It's not even going to be any good. It's going to be no good, kids. I'm sorry. All right, just keep doing it. I'll just call it ninth period. All right, so let's just go. If you want to find f of b in general, how do you find f of b given some other point in the derivative? It's f of a from a to b, right? Of f prime of x. When you integrate the derivative of a function from a to b, you get the change in that function. So whenever you want to use this, the x value of the given point has to be the lower limit of integration if you're going to use the plus. All right? So sometimes we say, I don't know what to put where. Okay? Well, it's f of a plus the definite integral from a to b. Now, b is the x coordinate. That's why you're trying to find. All right, so now I'm just going to have hope again. Nope, I'm going to put that down again. If we keep trying. Well, then you won't learn, right? Then you'll be. Doesn't matter. Does it sacrifice you? Okay. Yeah, come here. Gabby's going to take 15. All right. Sorry, that's. Oh, you can just shut that. Okay, so negative 0.311. Yeah? Oh, no. Okay, if you got something different, tell me what you got. You got it now? It's not just 4 tan x, it's 4 raised to the tan x. Make sure that's the right. Yep. Okay, it's always going to be, can you go back a screen? Nice. All right, so the lower limit is always the x-coordinate of the given point. All right, with a plus here. Now, if you want to switch them and then make it a minus, that's fine. But when you first write it out, this is just the fundamental theorem of calculus where we move the terms around. Okay, so the lower limit has to match. That's why I want you to always write it first as depth of something, then just fill in the value. Okay, now you can go ahead and scroll. So, yeah, if it bugs you that this lower limit is greater than the upper limit, you can switch them and make it minus, but you don't have to. When is the only time when you want to evaluate a definite integral where the lower limit does have to be less than the upper limit? Like if you're using a calculator, does it matter? No. I'm just thinking of something. Oh, God, it looked like you were thinking of something. Oh, okay. Yeah, well, when you say upper minus lower. Okay, the number line technique with the definite integrals, definitely it has to be lower there. But when you want to, you're absolutely right. And when you want to evaluate a definite integral, what if you don't have the derivative? Like you don't have an expression for it, you just have a graph of it. Oh, that's when the lower limit has to be less than the upper limit. When you look between the limits of integration, you take area above the x-axis minus area below. That's when the lower limit has to be. So if I didn't have what the derivative was, I didn't know it was 4 to the tan x. I just had a graph. I would have to switch them and then make it minus. And then I could look at the graph between -1 and 1 and take area above minus area below. We'll do that. We got to finish the gigantic problem, right? We're going to go to the gigantic problem from day 83. We're going to finish that first. And then we'll go over the homework problems. I think that's a better order to do things. Oh. I can't work with my left hand. Look at that. It's so bad. Oh, you know what? Sorry. I need to close this out because I need to go to the other day. Here it is. All right. Guys, what day were we on? I mean, what, not day, what part? E? Okay, for anyone that kind of missed the end, if you started packing up early or something, I don't know who would do that, but what was the area of this trapezoid? 4.5. And then we had to get the area. We got the area of both of these together. So all together, we didn't get that? Angel, I know I didn't start yelling at you. That doesn't make it sound like me. Angel, what are you saying? All right, we got to learn how to cut things out. Okay, so if you want the area of that, let's take it from there, because you're not going to be able to answer any of this until you get that area. Do we talk about how we would find it? Do we want the area of that shape? Okay, so we do need to find that out so we can, because to get definite integrals, you're going to have to use area when you're just given the graph of the function. So if you want this area, I don't know, you're going to take the area of the rectangle. That's the area of all this rectangle here, which would be what? What's the area of this rectangle here? If you base is 2, height is 1, so it's 2. Right? And we got to subtract the area of the semicircle. Does that make sense? If you take the area of a rectangle, you subtract the area of the semicircle, you'll be left with this shape over here. How do you get the area of a semicircle? Half pi r squared. Okay. So what is the radius of this circle? 1. Okay. So the area of the semicircle would be 1/2 pi times 1 squared, otherwise known as 1/2 pi, pi over 2. So the area of this region is 2 minus pi over 2. Now we can answer this question. So we didn't start E, right? Not really. Okay, we do have to set up a chart because when you're looking for the absolute max, where could it occur? We're the only possible place the absolute max endpoints. or at a relative max. And if you're looking at the graph of the derivative, how are you going to tell we have a relative max of a function? Positive to negative. Okay, so the only x's we have to look at are the endpoints, -5, and, oh yeah, 3, it's going from positive to negative. We have a relative max there, g prime is going from positive to negative. And the other endpoint is 4. All right, now we're talking. So we're going to find g of x at each of these values, and the greatest one is the absolute max. To get g of x, you're going to have to use the definition. So if you want g of, let's start down here at 4 because it's easier. If you want g of 4, what are you going to have to find? Good, Chris. So it's going to be the definite integral from -3 to 4 of f of t dt. How are we going to get the definite integral from -3 to 4 using the graph? Area above minus area below. And we got to look at the graph just between -3 and 4. It's a stretch over here. So between -3 and 4, you see most of the area is above. Actually, we didn't get this little piece over there. Let's get these other two. We got another little bit of area over here. What's that area? 0.5. And what's this little area, this little triangle here? Okay. So, if the definite integral from -3 to 4 is the total area above minus the area below, so what are we going to get for that? We're getting 0. No way. Starting, because the area above, you got the 4.5, you have the 2 minus pi over 2, you got the 0.5. The triangles will subtract off, right? Okay, so 4.5 plus 2 minus pi over 2. Right? So I'm going to clean that up. So instead of saying, well, so 6.5 minus pi over 2. Oh, we could combine those. Well, we could make them, right? We could combine that into a single term. You know you want to do it. How many halves is 6.5? So you have 13 halves minus... Bam, Angelo. Nice. Okay. Let's get g of 3. By the definition, how are we going to get g of 3? Nice. Definite integral from -3 to 3 of f of t. That didn't help anything. Alright, so it's going to be pretty close to g of 4. So it's the definite integral from -3 to 3 of f of t dt. So we look at the graph between -3 and 3. Oh, how nice. Oh, it's at 14 minus pi over 2. Yeah, it's just a 0.5 more than what you had before. Because you just add, there's nothing to subtract. It's all above. So if you add them up, you got the 5 plus the 2 minus pi over 2. So 7 minus pi over 2, or I like how you did that. Or 14 minus pi over 2. You can write 7 minus pi over 2. I like that better. So far, who's winning for the role of absolute max? Yeah. 3's y is greater so far. But we got to check out g of -5. Well, if you have to compare which of these is greater so far, because we're looking for the absolute max, this one's numerator is a little greater, so it's going to be greater. All right, so to get g of -5, and I'm just going to do that down here. If I just use the definition, it's equal to the definite integral from -3 to -5. if I want to get a definite integral using area, what do I got to do first? Flip them and negate it. Bam. So, sorry I'm not like freezing this, but so it's going to be minus the definite integral from -5 to -3. So I can still do area above minus area below between -5 and -3. I just have to negate it. But you're going to like this. Oh, we didn't get any areas over there. Oh, we got to stop. Got to get areas. What's the area of this triangle? Oh, that was good. I said 1. Right, 1/2 base times height. 1/2, 1 times 2. Right, I'm sorry to annoy you, but what's the area of this triangle? That one again. So the definite integral from -5 to -3 to area above minus area below, 0. And then when we negate it, it's still 0. So this is going to be 0, but the word for it is down here. Because we switched the limits of integration, when you're going to use the area method to find the value of the definite integral, the lower limit does have to be less than the upper limit. So it's -1 minus 1, but that's still 0. So these are the y values that we're comparing, and we're trying to find the absolute max. Oh, it says where does the absolute max occur? So where does it occur? X equals 3. Yeah, it has the greatest y value. So where does it occur at x equals 3? Question part F says, what is the absolute max? 14 minus pi over 2. That's the y coordinate. So where is it? You give the x coordinate. What is the max? You give the y coordinate. That's a little bit of fun. Okay. Oh, there's something down there, isn't there? Oh, do the extend page. Yeah, right there. Nice. On what intervals is G decreasing? You're looking at G prime. What are you looking for, first of all? A function's decreasing when its slope is what? Negative. So you're looking to see where G prime is negative. Should I trust you guys looking at the graph? I can't see it, but I'm just going to trust you. -5 to -3. Don't. I think it is to -3. Oh, I made up a different one. Okay. Oh. All right. So where? Yeah, you're right. I think we answered that already. Oh, we did that one already. Okay. So we're moving on to. Okay. All right. You'll never know the answer to that because we already did it. Yeah. Turn the page. I want to see where I put that. Oh, here it is. Okay. Sorry about that. All right. On what intervals is G concave up? Tell me about G prime, where G prime is increasing, where the slopes are increasing. That's where the graph will be concave up. So you're looking where G prime is increasing. All right, so -5 to -3. Now, you might say, oh, I don't know, -3, is that where it's increasing or it's decreasing? Well, you can put it, it's up to you if you want to include it or not. Let's include everyone. Yeah, it's not really increasing or decreasing there, but it's okay. Anywhere else? 1 to 2. Now, when you're talking about another interval, you use that. So for, yeah, 1 to 2. Nice. Just have to check it. I will include them. And that's it, right? On what interval or intervals is G concave down? So what are we looking for with G prime? Decreasing, okay? And the slopes are decreasing, so what do we think? -3 to 1. 2 to 4. All right. And you always have to justify any answer you give. And, saying that a function is concave, g is concave down when g prime is decreasing, that's your justification. More. Let's try more. Thanks. Wait. All right. Where does g have a point or points of inflection? This is g prime. Let's make it -3. Well, it's when the second derivative changes sign. This is the first derivative. You're right. Right. I'm just saying in general. Yes. Because the second derivative changes sign when the slope of the first derivative changes sign. So anytime it goes from like increasing to decreasing or decreasing to increasing, so -3. So we're looking for, let me just write this down. Slope of g prime changes sign. Or if you want to say g prime has a max or a min, that's the same thing. Okay, so you said x equals -3. X equals 1, I like that. It's going from decreasing to increasing, so slopes are going negative to positive. 2, yeah, that's good. That's good. You're going to love this one. You will. Average rate of change of a function over an interval. What if I said the average rate of change of f of x on the interval from a to b? That's the instantaneous rate of change. Slope of tangent line is the derivative. That's the slope at a single point. Average rate of change is the slope of the secant. It's just a regular slope formula. Change of y's over change of x's. Just remember, rate of change means slope. So, you have a graph and it's changing, its slope's changing. To get the average slope, we just take the slope from the first point to the last point. So, average rate of change of g on the interval from -3 to 2, we're going to have to figure out g of 2 minus, let's go ahead and do change of y's on top, minus g of -3 over, I got to get the order right. What's the order for the 2 minus -3? Right? Change of y's over change of x's. Keep the same order. All right, I'll do the denominator. You guys do the numerator. No? All right. You know what? I'll let you do half of the numerator. I'll do the g of -3. All right, you do the g of 2? Really? It's like never enough. It's never enough. All right, how are we going to get g of 2? Oh, yeah, from -3 to 2. All right, so to get just this part here, the y coordinate 2, we got to get g of 2. I got to write this down here. So g, this is not ridiculous, in case you're thinking that. Oh my gosh, we got to get the definite interval from -3 to 2. Easy schmeezy. How do you get the definite interval from the area? Area above minus area below. Just look between -3 and 2. Oh, we've already done that. Remember what that was? That whole cleaned up version we had of it? Was it really 14? Yeah. Figured that out already. That was 13 minus pi over 2. Remember we took the area from -3 to 2. So this area was 4.5. You don't remember that? And then this area, these guys, it was the area of the rectangle 2 minus the area of the semicircle minus pi over 2. Well, this is 9/2, and this was 2 or 4/2 minus pi over 2. So now that's just the g of 2. All right, what's the g of -3? 0. Definite interval from -3 to -3. That area would be 0 all over 5. All right, clean. This doesn't look so nice. Complex fractions. So what do we get? I don't know whether I should put this 5 up with the numerator, the denominator. Does it matter? You want to put in the numerator? Okay, what's the flip? Okay, so I'm going to keep the 13 minus pi over 2. So you're just going to change division multiplication. You're just going to multiply by 5? Change it. Yeah, multiply by 1/5, right? 13 minus pi over 10. Anytime you have a fraction over something else, just picture this down here, just jumping into the denominator. Right? A fraction, a over b over c is just a over b times c. Or do your little keep change flip. All right, that's the average rate of change. Average rate of change. Change of y's over change of x's. All right, now comes these just get better and better. Find the second derivative of g at 4. It's the slope of g prime, the second derivative. Right? It's the derivative of the derivative, so it's the slope of the derivative. Derivative, you just translate in your head meaning slope graphically. The derivative of the derivative? No, the second derivative, making this up, is the derivative of the first derivative, right? Okay? And graphically, the derivative means slope. So this just means the slope of the first derivative, that, at x equals negative 4. So look at that graph at x equals negative 4 and tell me what the slope is. Let's flip together. What? Slope here is 0? No way. The slope at any single point on this line is the same. You just got to know the slope of the line. It is 2. Change of y's over change of x's, right? Rise over run. Up 2 over 1. So it just equals 2. Every single point on a line has the same slope. That's why it's a line. So you might want to make a note to yourself, the slope of g prime at x equals 4. Oh, Gabby, go ahead. Thanks. Okay, L. Write the equation of the tangent line to g at x equals 4. Now, in general, how do you write the equation of the tangent line to some function g at x equals 4? Okay, y minus, how would you get y1 though? Yeah, but if the function is called g, is it g of 4 or g prime of 4? Yeah, that's what I'm talking about, g of 4. So y minus y1 equals g prime of 4. Is somebody cooking dinner? Do you smell that? Oh, okay. Doesn't smell like popcorn. You should smell like chicken. Someone's cooking chicken. Like the English classes, they do that. All right. Oh my gosh. So we have to just get these two numbers, and we've got it. All right. I'll do the g prime of 4. You do the g of 4. It's all right, because you know what? G of 4, we already figured that one out, didn't we? Right? So I'll play your game. So y minus 13 minus pi over 2. G prime of 4, that's the easy one, because you're looking at a graph of G prime. G prime of 4, if you read that graph is y equals G prime of x. Look at the graph. Yeah, negative 1. So negative 1 minus 4. Done. We just leave it? Yep. One more. Ready? Okay. When you're asked to write an explicit equation for g of x, they just want you to write g of x equals. They don't want g of x plus a tree or plus, minus x or anything else. They just want to know what g of x equals. Explicit. So we got to solve for g of x. Well, it's a pretty big task. You can't just do it automatically. You've got a graph of g prime of x. And we're going to do this on the interval from negative 5 to negative 3. Look at this graph between negative 5 and negative 3. What is it? It's a line. Can you write the equation of a line that you're looking at? Yeah, you can. What do you need to write the equation of a line? The slope. Now, B would be nice, but I don't know where that thing's going to hit. So what else? What's another way to write the equation? Point slope. You pick one point on that line, and please pick the easy point. You have all these points to work with. Give me the easiest one. That's not a point. Okay, so we're going to use the point -4, 0. And what's the slope of this line? 2. So let's write the equation of that line. That's g prime of x. So let's first write it. So y minus 0 equals 2 times x plus 4. So y just equals 2x plus 8. But instead of saying y equals, that's g prime of x, right? That y on that graph is g prime of x. So we start this by writing g prime of x equals 2x plus 8. You write an equation for g prime because that's what you're looking at. And you can only be asked to do this if it's linear. But they didn't want an equation for g prime of x. They want an equation for g of x. Wait. Oh, how did that work? Okay. Let's take the antiderivative. Okay. Okay, now here's the thing. If you want to solve for c on the graph of g of x, you need 1 point on the graph of g of x for some x in between -5 and -3. Now, we're not going to take a point off the graph of g prime. Look at values for g that we found. Okay, we know what g of -5 is, so we'll use that point. We know that g of -5, do you remember what we got for that? That was 0. So you could have used g of -3 equals 0 also. That's a good one. Now, what goes where? I got a 50-50 shot. Yeah. What's in here is the x. So the -5 goes into the x. The 0 goes into the g of x. Positive 15? I think that's right. So, wait, where did what? So now we know what g of x is. It's x squared plus 8x plus 15. Does it make sense? Guys, does it make sense looking back? Gabby, you gotta take me back to the graph. That if this is a graph of the derivative from -5 to -3, it's linear, that g of x, the actual function, is quadratic, it's a parabola. Right? When you take the derivative of a quadratic, it goes down and it's linear. Yeah. Okay, now, I didn't go over any of the homework, which is bad, but I typed out the answers. Maybe now it'll be a little easier for you to look back over it. Yeah. Yeah, I think it's going to be a little better. Don't do anything. Now, look at these AP problems. First of all, does everyone know where Palios' office is? Okay, because that's where you see the foreign language in the corner there, the new wing. Those checks in the yellow forms are due by Friday. They say that they won't accept them afterwards. So you want to make a note to yourself. Remember, you can always back out, but you can't back in. I think that's how they, I don't know if that shouldn't have been said. Okay, then, oh yeah, you can hit the pause. Bye, everyone.